Okay, guys, welcome to your third tutorial. We're going to be doing some more practical coding. So let me quickly just pull up our Google Chrome. Okay. So you can see on the screen here what we're going to be covering today, which is stuff to do with 2D lists. And I don't think you've seen 2D lists in your assignments yet, if I'm correct. But it is really important because, and I can't confirm this for sure because I don't know what's on your test one, but I think you might see some two-dimensional list stuff on test one, since I believe Mr. Moore would have covered it by now in lecture. So this is a really useful tutorial in the event that you get asked on test one for 2D list stuff. And even if you don't, you're going to be asked a lot on 2D lists later on because they're a very fundamental part of programming. And it's very important that you guys know how to use them and manipulate them yourselves. So we have a bunch of little mini tasks that we're going to be covering today. And so you can see the first one here is we're going to use while loops and empty lists and the append function to write a function that creates a 2D list. And obviously for anyone who doesn't know yet, a 2D list is just a list of lists. Lists can contain anything for elements, and those elements can be a list themselves. So if the element of a list is a list itself, then you basically have a list of lists, right? And what this 2D list is going to do in this case is it's going to correspond to a times table. So we're going to do the whole times table, probably up to like 12 by 12 or something, or we can make it like a variable, so that the user can pick whatever they want their times table to be. That'd be pretty cool. And basically, every row of our 2D list is going to be a different times table, right? So we're going to have like the 1 times table, the 2 times table, and so on. So, give me one sec. Okay, so we can start here and create a new cell. And we can try and create this first subtask here. So let's set up a function. We can call it generate times table. And for now, we're going to leave it without any sort of input. And we're just going to have it generate a fixed size times table. And let's do 12 for now. So we're going to say up here, the comment for this is this function generates a 12 by 12 times table in the form of a 2D list. And so what you guys need to know is that a 2D list obviously contains, it consists of rather, an outer list. And then within that one outer list, all of the inner sublists, right? So we're going to have one outer list, and we can just define it as an empty list for now. And it's going to have 12 sublists inside of it. So we want to append 12 empty lists inside our big outer list. And that way we're going to have one big outer list and then 12 empty lists, all within that one outer list. So I'll show you guys how that would be done. We'd have something like this, and we would append an empty list there, right? And so you can do that. You can just append an empty list in this exact fashion. And if we just stop here and we say print, and then we call our times table function, well, assuming you actually return the outer list, which I forgot to do. If you run this here, you notice that we get a 2D list where these outer brackets correspond to the outer list. And then inside that one big list, we have 12 elements, and each element is an empty list within itself. So what we're going to be doing is we're going to actually populate each of these inner lists with the times table. And you guys might already be figuring out how to do that. And that's with a second for loop. And so what's very common is that when you guys do any sort of manipulation with 2D lists, double for loops are very commonly going to show up. And the reason for that is because if you want to access or reference a single a single element in a 2D list, then you need to somehow reference which row you're talking about, and then you need to reference which column you're talking about, which takes two indices. So we have one index here for the row, and one index here for the column. Alternatively, you can think about it as one index for your outer list, right? You want to say which sublist you're talking about, so you have to index your outer list. Like let's say you want to talk about this list, and then this list might contain, I can actually edit it, I just realized, but this list might contain like XYZ. So you need one index to specify this inner list, and then another index to specify which element of that inner list you want to refer to. So that's why you're going to need two indices, and that's why you're going to have a double for loop show up very often. And so now we can just repeat once again for j in range 12, right? Notice that we need to use a different index for our two for loops. We can't use the same one because I is already taken up here, so we need to use j. I see a question in the chat. I'm going to read it as soon as I finish this example, okay? So for j in range 12, which is our inner list, we're going to want to append the times table to each sublist that we're referring to. So we can do that by appending I times j. And you'll notice here that basically for every I, which means for every inner list, we're going to append I times j 12 times to it. And so j is going to go up for each I from 0 to 11. And so you see here, if we return what I have right now, we'll get something like that, which is not very legible, but not to worry, there's a way that we can get around it. And instead of just printing our times table just like that, we can say, we can store our times table, we can store the result in some sort of variable, like this. Notice that we're calling this function, which returns a 2D list. So this function returns a 2D list, and this assignment stores whatever this function returns in this variable. So we're storing the 2D list that's returned from here in this variable. And now we can actually say for I in range, for I in my times table, print I. And the print function, by default, after it prints something, it inserts a new line. So after it prints, after you print anything, a new line will automatically be inserted afterwards, which means that if we print each row on its own, like this, then it's actually going to be separated, by row, like this, which makes it a lot more easy to read. And then here you can actually legibly see that this is a times table. We have a 0 column and a 0 row, which is not very useful. But if you think about it, that technically would be the 0 times table there. And we can easily fix that, right? By let's see what's going on here. We have an index there. Outer at I dot append I times j. So this is going out of index, and our I is going from 1 to 13. So I think I'm actually not sure what's going on. Let's just start at 1. And we're inserting a list for every I, which is 1 through 13. And for every j, we should just be going to the same value. Okay, so we'll go back to our initial here for a second. we can see here that this goes up to, this is the 12 times table up to 11. Which means that if we push it further, yeah, we get a 12 times table up to 12. All right, I'll look into that. That's just an arithmetic mistake I'm making, but I'll quickly check the question in the chat now, which is referring to Jupyter Hub. So Jupyter Hub has been running into a lot of stupid errors on code that worked earlier and sometimes doesn't run at all. What can we do to run our code? So that's a pretty vague question. Unfortunately, there's like a lot of different things that could be happening. Obviously, there's a possibility that JHub is messing up, but there's also a possibility that like something's going on in your notebook specifically. So if you're having trouble, feel free to reach out to me like afterwards on Microsoft Teams. Just send me a message, and yeah, that's weird, Akram. Just send me a message afterwards, and I'll take a look. But it shouldn't be JHub. It would be really weird if it worked yesterday, and it didn't work today. So yeah, we can figure that out later. For now, this is the times table. You can see that we formatted it clearly over here, and if we wanted to, we could actually make this function a variable function, which means instead of generating a fixed length times table, we could generate a variable times table. So we could take in a variable here, we can call it size, and then instead of using 13 here, we can actually refer to our size variable, and now whoever calls this function would have to call it with a variable that they're passing in, and that variable would be the size. So here we can actually pass in a variable. We could say 10, for example, and then this would be our 10 times table. And notice that this is actually only going up to 9. So we should use size plus 1 over here. Because notice that the range in Python is always exclusive for the ending, which means that if you have a range going from x to y, that range will start on x and go up to y minus 1. If you want to actually include y in that range, you have to obviously increase it by 1, which is what we're doing here, by 1, not by exclamation point. And you can see here that now when we call it with 10 as our input variable, we're getting the correct output. And the beauty of this is that you can very quickly change it. Instead of having to change multiple fields in a function, we can just change it over here like to 30, and this would be absolutely massive, but this would be your 30 times table. Here's the 20 times table, and so on. So hopefully that explains kind of what a 2D list is at the very base. Feel free to ask any questions right now about the actual times table itself, but more importantly, if you guys have any questions regarding the 2D list and how that works, please ask it now, because that's pretty important. We're going to be going over a couple more examples about 2D lists, so if there's something that you don't totally understand, don't worry about it too much. You'll hopefully understand by the end of the tutorial, but feel free to ask any questions when you get them. Okay, I'm going to wait a couple more seconds, and then we can just start our second mini task here, which is to write a function that takes a 2D list, right? So a list of lists, and generates a string where the row elements are separated by the tab character, and the rows are separated by newline characters. And we're going to return the string from the function and show you guys how you can print that string separately from the function. So basically what we're doing here is, let's say, and here I'll make a new cell real quick right here so you guys can see it. Let's say what we have is some sort of 2D list like this. And let's say we have A, B, just like that. And here we have just one element in this list, C. And here we have D, E, F. Basically, this is a 2D list, which means it's a list of lists again. And what we want to do is, if this is the input to our function that we're defining up here, right? If this is the input to function 2, then the output should be like this. Here, output string, and look at what it says. It says the row elements are separated by the tab character, and the rows themselves are separated by newline characters. When they say row and columns here, what they kind of mean is that if you were to format this, what you would actually do is you would separate each sublist as a separate row. So when people refer to a 2D list's rows and its columns, by rows they mean the inner lists, and columns they mean like the ith element of each sublist. Because basically, if I were to show you guys, oops, that's not what I meant to do. If I were to show you guys like this, how this looks like, this is kind of how people imagine 2D lists, right? They imagine it like this. So here you can very clearly see what a row is and what a column is, right? A row would be A, B, for example, or C, or D, E, and F. It's just these sublists. And a column would be, for example, the first element of every row, right? So here, for this example, the row elements are separated by a tab character. So we would have something like A. Oops, let me turn this into a markdown cell. For some reason, it doesn't let me actually use the tab command. It's kind of weird. So I'm just going to say tab, tab B, right? And we want to separate the actual rows by new lines. So the output would be like this. New line. Then we have C, and then we have another new line, and then we have D, tab, E, tab, F. And this would all be formatted as a string itself. So that's all we have to do. And once again, this can be done by manipulating 2D lists using two nested for loops. And that's what these are called, by the way. When we use two loops like this, where one loop is inside the other loop, they're called nested. Because basically, for every iteration of this outer loop, this for loop will run its full length. So if just for clarity, I had this back to 12, just so you guys understand what's going on. On the first iteration of this for loop, so this one's going to run 12 times, right, from 0 to 11. On this first time, this inner loop is going to run all 12 times, from 0 all the way up to 11. And then this for loop will increment again. It'll go from 0 to 1. And then this will run again all 12 times, and so on until this outer loop has finished. And by the end of that, you would notice that this inner loop would have ran 144 times, 12 times 12, which is kind of how nested for loops work. So you can use that to your advantage a lot. But I'll show you guys how to do that for string formatting, which is what we're doing here. And here we go. Okay, so we can call this one, so we're actually going to be using a string command called join, which I believe Mr. Moore has shown you guys some of these string functions that you guys can use, which are native to Python. So Python has a bunch of functions which you can use to operate on strings. And I think he might even have some sort of document on Avenue content, which gives you guys a rundown of all the different commands that you guys can use, which are Python string related, right? So one of them, which is really important, is join. And what join does is you give it some sort of joining element, and then you give it a list. And it will basically create a string made up of all of those elements joined together with that string as the connector. And I'll show you guys exactly what I mean by that. So for example, if you had a string where it was just a period, you could do something like this. you could pass in a list to the join, right? So notice how we're calling the join on the string, and we're passing in some sort of list, right? We can pass in, for example, hi. Oops, I ran it by mistake. Hi, hello, and bye. And we can just print that for now. By storing it in a variable and then printing that variable. And now if we just get rid of this for a second, right? And if we run that function, notice what's happened here. This function has actually printed a string, which was basically this list of elements all strung together, kind of glued together, using this separator, this string as a separator. So we call this string that we call join on, we call this the separator because it is what separates each of the elements that we're joining together. And then obviously in the join function, you just pass in a list containing the elements that you want to join together. So hopefully that makes a bit of sense. And this is what we're going to be using to create this output from this input. So now we can put our 2D list back in here as our input. And we're going to be using this. Sorry. We're going to be using this 2D list to actually generate the output that we're looking for. So what we want to do here is we need some sort of like temporary list that we're going to be appending all of our row elements to, and then some sort of outer list that we're going to be kind of gluing everything together in. So I'll show you guys what I'm doing, and if anyone has any questions, just keep them to the very end because this one is going to make a lot more sense at the end when I can kind of run through what the function has done. But I'll still go through my thought process here. So we need to create, first of all, the inner elements. The inner elements are all going to be separated by a tab. So we want each row to be separated by a tab. So we're going to store the result of that in a list. And the way we're going to do that is we're going to say for every row in our 2D list, we're going to append to this list that we've created the joined elements. So we obviously want to separate them by a tab. And tabs are special characters in Python that can be represented with the \t. So if you print something like this, it'll actually represent itself as a tab character. If I just comment this out real quick, and I print hello, and then I put a \t here, and then I say goodbye, notice that what comes out isn't hello \t goodbye. What comes out is an actual tab character. So Python actually interprets these as their respective commands. Oops. \t is for a tab character. And I'm sure you guys can guess, \n is for a new line character. And so if we put \n over here, instead of putting a tab in between hello and goodbye, you guys can guess that it's actually going to be a new line. So hopefully that makes sense. And that's what we're going to use for this function. And so we're going to call our join function because our tab character is going to be our separator here. And we're going to call it on this row that we're using. So basically for every single row, we're going to join all of the row elements in a string, and then we're going to append that string to a empty list, right? And then at the end, what we're going to do is we're going to join together every string that we've created in this temp into its own final string, right? Because we kind of have to do it in a nested way in order to first cover all of our inner sublists, which are the rows, and then cover the final full 2D list, which are by combining every row, which is what we're being asked to do, right? We have to combine every row and separate them by new lines. So here we're combining every row element and separating it by a tab. And then out of the for loop, we can call this our final string. And this is going to be every element in our temp list joined together separated by a new line. And now all we have to do is we return that final string that we've created, and it should represent exactly what we want, right? And we'll give it a test out here. We can try and create a 2D list for us to test our function on. Let's say, for example, this is one of the inner lists, just like this. And we can have more lists, like, let's use some T names. We have Basil, Mark, Anna, right? And here we can have a separate list and call it Mr. Moore. And if we run this, so notice how it's actually not formatting because we're actually not printing it. We're just calling the function. And so the output of this function goes directly to what's called standard output. And you can see that because it says out 21 down here. Now to avoid that, what you can easily do is just print it, which is what you should usually be doing because the print function is actually going to format these \t\n characters just like that. So you want to make sure that you're actually printing. And now, if I just comment out what we were printing earlier, you can see that this function now does exactly what we wanted it to do, which was create a string out of our 2D list and have every row element separated by a tab and every row separated by a new line. So you can compare this output to what the function asks for and see that it is basically the same thing. And this part down here, where we can show that this string can actually be generated regardless from the function, is just saying that you don't actually need a function to run the string or to generate this output from the string. You can simply just do it outside of a function, which is as easy as just having some sort of to-do list, right? If you have something like this, some 2D list, like that, you can actually do exactly what we have here, right? Even if I comment all this stuff out, and we just tab this back in, you can see that this is actually going to do the exact same thing. I'll just comment this out real quick. And instead of saying list 2D, obviously we would use our new 2D list that we're using, just like that, and we get the exact same output. So you don't necessarily need a function to do everything, but the nice part about it is, if we wanted to use many different lists instead of just this one 2D list, we could do it a lot more easily with this function. So once again, guys, just as a reminder, this is going to go up on Avenue under our T02 tutorial section folder in the Avenue content, so you guys can always check out what we do in tutorial afterwards. And does anybody have any questions about this function that we've created here, or 2D lists in general and how they work? I'm just going to pause for a little bit and wait for questions. And in the meantime, you guys can read our third function that we're going to implement. And we'll start it in a minute. Okay. Doesn't seem like there are any questions. I'll continue for now, and if any questions come up, we can always come back to them later on. So we'll just comment this out for now, put this up here, and I'm going to say following code is for without a function. Okay, so let's insert a cell right above here, and this is going to be our third function. So let's take a look at what we're doing here. Given a to-do list and some value, so we have two inputs to this function. We have a to-do list and a value. We want our function to determine whether or not the to-do list that we're given contains that value. And here it says you're encouraged to use for loops and the in operator. And so this is pretty simple. Here's what we can do. We can say, let's first define our function. So we can say, what should we call this? We can call it, let's call it search to-do list, right? And what does it take in? It takes in a to-do list, and obviously we can name that anything. We can call it X, we can call it A, we can call it list2D, which I like to do sometimes to show you guys that it's a to-do list, but I also don't like to do it because sometimes you guys think that these variable names have to be called something. We can call them whatever we want, right? But we'll list that here, and we'll say value, which is the value that we're searching for. And so now in our function, we have to find some way to figure out if this value pops up anywhere in our to-do list, right? So for an example here, right, we might have, let's say a list of numbers, a to-do list of integers. We might have something like this. And I want to make sure that you guys know that they don't have to be the same size. Each row or each sublist, right, is the same thing. Does not have to be the same size in a to-do list. It can be whatever you guys want it to be. 10, 11, 15. And here we can say 8, 8, 8, 4, 2, 1, for example, right? So now we have a to-do list, right? It's a list of lists. And for example, we would want, given the above to-do list, does that list contain some value? For example, 9. And the output would be false, right? Because it does not contain 9. And so how would we do that? We can actually use, as the hint suggests over here, we can use the in operator in Python. So what in does is, I can actually show you guys what in does. It basically tells you whether or not a value is in a list. So you can say 4 in 1427. And you can see here that Python outputs true, right? If you said 5 in 1427, you can see that the output is false because 5 is not in 1427. If you could put anything here, you could put a string, you could say hello in 1427, and this would be false because this string does not show up in this list. But let's say we added that string somewhere here, like this, and now we ran this function. Notice how we get true. So that's what the in operator does. How the in operator works, right? And now all we have to do is we have to check to make sure that we have to determine whether this value that we have is in any of these lists. Because basically, if we were looking for 9, we can't actually say, some of you guys might be saying, oh, you can just check to see if this value is in your to-do list. You guys actually can't do that, and I'll show you why. If we said answer is equal to value in list2D, and then here we returned our answer, right? Let's try calling this. Let's try calling it search 2D list and we'll pass in, let's actually assign this to a variable. We'll call it sample 2D list, right? If we pass that in here, I'm sure some of you guys might think that if we passed in a value of, for example, 4, okay, so the way that we define this is actually not valid because we need commas. If we run this again, you'll see that we get false. We get false because even though 4 is in this 2D list, which means technically it should say true, the reason it says false is because it's only looking in the outer, in this list's most like surface level elements, right? So what are the elements of sample 2D list? Can anybody in the chat tell me how many elements sample 2D list has? Just throw some guesses out there. How many elements does sample 2D list have? And that'll give you a big hint, if you guys get it right, as to why this function is not working. Any guesses? Yeah, someone got it. So it's actually 3 elements. And that should kind of tell you guys why this is not working, is because the only elements in this list are these 3 lists. So when you check to see if 4 is in that list, it checks, is this element equal to 4? No. Is this element equal to 4? No. Is this element equal to 4? It does not go inside the sublists. It doesn't even care that these sublists are lists themselves. It doesn't care if it's a list or if it's a number or if it's just a string. It just checks to see if that element itself on the surface level is equal to what we're searching for. Which is why, if we want to do what this function requires, we actually have to dive in ourselves into each sublist and check to see if each sublist contains the value that we're looking for. So, knowing that, we can kind of continue here. And what we'd want to do now is we would say for, and here we can say sublist, right? We can call this anything. This is just the name of our iterating variable, our looping variable. For sublist in list2d, if the value is in that sublist, return true. And if it's not, if the value is actually not in the sublist that we're looking for, that means that Python, our function, would manage to make it through this whole for loop without ever actually returning true, because this conditional would never be true, right? If the value is not in any of the sublists, then this will never be true, which means Python never reaches here, which means that Python would make it over here, over to this part of our function, which means here we can actually say return false. And that's because if our function actually makes it to this part in the execution, then we know for a fact that it never found the value in the 2D list, because if it did, then it would have returned true and the function execution would have stopped right there. It would have stopped as soon as it returned true, because as soon as you return a value, as you know, the function stops right there. So here you can see that, like, if we just get rid of this, right? Now if we run our function again, we actually get true, which is exactly what should happen, right? Because 4 is in this 2D list. It actually pops up more than once. It pops up 3 times. If we put in 15, which only pops up once, it pops up right here, we'd still get true, as you can see, because basically what's going on in our function is it checks every sublist in our 2D list. It checks this list, it checks is the value, which is 15. Is 15 in that list? No. So we go on to the next one. Is 15 in this list? Yes. So we return true, and our function terminates on the spot. And then you can see that if we look for 9 over here, we get false. And that's because there is no 9 in the 2D list. So in some ways, this function is actually probably the simplest one that we've coded today. It really just depends on you understanding how this in keyword works. Yeah, so that's basically all of today's tutorial content. If anybody has any sort of questions that they'd want to go over, feel free to ask them. If it's about 2D lists, or if it's about something to do with the course or Jupyter Hub or even assignment 2, feel free to ask. And I'm going to stick around for the next 10 minutes because we're basically done tutorial. But yeah, feel free to ask any questions. So we have a request here, which is to do coding bat list 2 sum 67. So let me try that out. List 2. Just give me 1 second. That's weird. I'm trying to. Here we go. Okay, so hopefully you guys can see that. All right, let's take a look. Return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 7. Every 6 will be followed by at least one 7. Return 0 for no numbers. Okay, so this is actually a pretty interesting one. I haven't done this one before, but we can definitely try and think about how we would approach it. So what we know is that we're going to be returning a sum, right? That sum might be 0. So let's just call that result for now. It might be 0, it might be more. So we can define that initially. And actually, let me zoom in here so you can see a little bit better. We can initialize that variable to 0 over here. And we're going to need to find some way of figuring out when we have a 6 here, because all of these numbers aren't actually going to be counted towards our sum, because they're between the 6 and the 7, and the 6 and the 7 actually won't be counted either. So this is not too bad. Basically, what we can do is we can have some sort of way of determining if it's a 6 or not. We can call it found a 6, and we can declare it as false. And what we're going to do is we're going to iterate over every single number in the list. And we're going to see if it's a 6. If it's a 6, then we're going to mark our Boolean variable that we've declared as true. And we're going to advance. And if it's not, if it's not a 6, then we're going to add the number that we're looking at to our sum, and we're going to move on. So we can say here something like for I in nums. Yeah. Let's say for I in nums. And now we're going to have a conditional. So we're going to say if I is equal to 6, then we're going to say found a 6 equals to true, right? And what else do we have? Okay. So we want to say another condition is let's see. Well, there's obviously going to be the condition where we have to just add, which is true if found a6 is not true. So if found a6 is not equal to true, then we can just add the current number to our results. So result plus equals I, yeah. And now there's one more condition, which is where we have to end our found a6, right? Which is when we get to the 7. So now here's what a lot of people might make a mistake doing. They might say, if I is equal to 7, they might say something like this. Found a6 is equal to false. Now, what would be wrong about this part of our function? I want you guys to try and think about that. If anybody has any ideas, feel free to message it in the chat. There's a very specific reason why this would not work. And just for the sake of time, I'm going to go over it. And that's because it's not any time that you encounter a 7 that you want to set found a6 to false. It's actually only if you're already at true. But then again, I'm actually just realizing that this would not matter because if you're setting it to false and it's already false, then it really doesn't matter. But yeah, so it actually doesn't matter. But just for the sake of like clarity and understanding, I'm going to leave that in there. So I'm going to say if found a6 is equal to true, and I is equal to 7, then found a6 is equal to false. And with that, we should be done. I'm obviously not sure if this is going to work perfectly, but I think that's basically the extent of it. Yeah, so we're good there. And I'll take this and I'll put this in here as well, just for people to have it. I'm going to say list 2 sum 67, or sum 67, I guess. And we're going to have that there. Cool. So hopefully that helps out. Sorry about that, guys. Excuse me. Okay, cool. So I'll leave that there. Save and checkpoint again. Next question. Could you go over question 3b in assignment 2? Okay, let me try and do that. Temp A2. Hopefully I don't have answers in here. Oh, this is not even the right course. Oops. Okay, hopefully this is the right one. Okay, so it's question 3b again, right? Yeah, question 3b. So, in order to understand question 3b, you have to understand question 3a. But basically, question 3b wants you to calculate the number of times that each of our creatures, whatever they are, plays pinball in a given month. So you're going to specify how many days are in the month. That's going to be given to you for every function call. And you're also going to specify what day of the week you're starting on. And that's it. And I mean, it doesn't have to be an actual number of days that would occur in a month. It can be anything. But you're basically saying we're going to start on this day of the week, and we're going to go on for this many days. And every day of the week, only one of the creatures is going to play pinball. So in every day of the week, these numbers, one of these numbers is going to go up, and it's going to go up by exactly 1, right? So all you have to do, assuming your answer for question 3A is correct, if you have a correct answer for 3A and you know it, then all you have to do is basically just go over every single day and basically see who's playing. You have to keep track of how many times each creature has played, and then you have to return that over here. So I can't obviously give you guys the exact answer, but I can kind of give you guys the thought process here. Oh, and obviously you have to use this ink day, which is very useful. So what you can do is you can say cur day is equal to starting day, for example. And then you guys can say something like, you can keep a list of the number of times each person has played. So what are they called? You can say like inky count equals 0, right? Whatever, blah, blah, blah. And you can change these to Blinky, Pinky, and Clyde. And so you have these counters, right? And over here, you would have some sort of way to check what it is. And notice that you're going to have basically something that goes along the lines of for I in range days in month, right? And you're going to have some sort of thing where you basically, and I'm not going to do all the code here, but I'm going to say store, or rather determine who plays pinball on this day, right? And here each day, or sorry, each iteration of this for loop is basically a different day. And then you're going to increment the correct counter accordingly, right? Depending on who actually plays that day. If you know that Inky played on a given day, then you're going to increment Inky's counter by 1, right? And then you're going to call your inkday command, or sorry, inkday function rather, on your current day, which basically, or rather I should say, increments your current day using inkday. And the way you can do that is something like this, right? Cur day is equal to inkday cur day, right? Because what this function does is it takes in as input a day of the week, and it just returns the next day. So if you give it Sunday, it'll give you back Monday. So if you want to turn Sunday into Monday, all you have to do is assign the current day a value of this function, and you pass in your current day. So if current day currently has Tuesday, this function is going to take in Tuesday, it'll spit out Wednesday, and then you'd basically be storing Wednesday into the variable that previously used to store Tuesday. So you can see how that's going to work, right? And then the last thing you have to do, which is going to be outside of your for loop, is last thing you have to do is turn format your counters as a tuple, right? Because they want something like this. They want the output to be a tuple. And the way you can do that is you can just do this. You could say result is equal to tuple. You can use this tuple function. And if you guys don't really know how this works, feel free to Google Python tuple function, right? And you'll find out exactly how this works. And you can store in here like every counter that you have, sort of just like this. And notice how I'm actually putting it in a list. I'm kind of formatting as a list because I think you need to pass in a list. I don't think you can pass in individual things and it'll put it as a tuple, but you can convert a list into a tuple. So if you format it as a list and then turn it into a tuple like this, that would work. Cool. Does that help out, Alex? This is kind of like, you know, how I would think of the problem and how I would approach the problem. And really, I kind of showed how you would do this right here. And these two steps are very, very simple to do on their own. Like it's very quick. They're probably like one line each. So not too difficult to fill in the remaining work to be done over here. I would actually recommend that you don't use global variables. Global variables have a very niche use, right? A very specific use, and typically you use them when you're doing recursion. You do not need global variables at all over here. And yeah, I would definitely stay away from global variables until you need them. And you will be informed when you need global variables. But for now, do not worry about them. You absolutely don't need to use them. Everything that I've laid out here is more than enough to do this question. Yeah. And Maitreyi, I'm glad you guys found it helpful. Cool. So yeah, that's 3B. Ju Hu asked for 3B as well as 4B. And we're a little bit over time, but I'll have a quick look at 4B. So yeah, I'm not going to be posting this anywhere, but you know, you guys can look at it now, and obviously this recording will also be on YouTube, but yeah, feel free to take a look now if you need it and refer to it later on. But let's go back to 4B for now. Triple letter grade. Okay, this one's actually very simple. I took a quick look at Piazza, and I noticed some people were having some trouble with this one. So it's actually kind of good that you mentioned this because I want to clarify just how simple this actually is. You're given 3 scores, right? And if you notice in 4A, right, assuming that you did 4A right again, like notice how 3B depended on 3A. In the same way, 4B depends on 4A. And actually for this one, if you have 4A correct, 4B is extremely simple. And it relies on one concept exactly, and that's string concatenation, right? This function is actually so simple that like if I gave you guys like any actual help, I would basically be giving you guys the function because it's literally like one line. Like you could actually have the function completed by just filling out this return statement here. Like it's basically something along the lines of a plus b plus c, right? Is your whole function. Because notice what's happening here. Your function that you defined up here in 4a defines some sort of function which takes in a score as an input and then spits out the letter grade for that score as the output. So if you have 3 scores, which are student 1, student 2, and student 3, you want to take all of their letter grade outputs, which notice how 4a, this function returns a string. You want to take those strings and you want to glue them all together. Oh, Alex, I'm sorry to hear that. Maybe you were the person who I saw in Piazza. But yeah, it's if you take advantage of 4a, it's very simple. It's actually just one line, right? And if you take a look at this, a plus b plus c, this format, you might realize what's going on here, right? All you need to do is compute the letter grade of student 1, which is going to be a B, and 88 gets you a B in this first example, right? Yeah, Juhu, you're saying, should I repeat 4a code like 3 times? You don't even need to repeat the 4a code. You can just call the function that you defined in 4a 3 times. And you can actually call the function 3 times on this same line, because all you need to do is you need to concatenate those 3 strings together. When you call this letter grade function on student 1's grade, it'll give you B, which is a string. When you call letter grade function on student 2's grade, which is 99, it'll give you A. When you call letter grade on this 55, which is student 3, right, you get a D. You just have to return the string concatenation, which means when you glue strings together, right? And hopefully this will help out, right? If I say A is equal to B, sorry, maybe this is confusing, right? But if I say x is equal to B, y is equal to D, and z is equal to f, right? These are just three variables that I've assigned strings to, right? If I say print x plus y plus z, oops, sorry. It's because it thinks that we're still in this function. So let me just actually raise a not implemented error. Should be up here. Cool. If I run this, notice that it gives you the string like that. So over here, if I were to just run this and I were to say x plus y plus z is equal to the string BDF, we get true, because when you just use the plus sign with strings, you concatenate them. So all you need to do is concatenate the results that you get from calling your previous function on all three of the students that are passed in. These parameters, these input variables, are holding integers. These input variables are holding these three integers. They're holding the grades for student 1, student 2, and student 3 respectively, right? They're holding their grades. So if you just call the function that you defined up there on these three variables, you will get strings. If you concatenate the three strings that you get from calling that function on each of these things, you will get your final answer, which is what you're looking for. Okay. So yeah, this is actually a really simple question. So I will definitely not go more into detail about how to solve it than that, because I feel like that's more than enough actually. But yeah, please feel free to refer back to it. And yeah, you can very much do this in one line of code if you want to. Okay. Cool. So yeah, I think that's all the questions that we got. I think it was just 3B and 4B, if I can see correctly. And the coding bat solution is on the notebook that we did up here. So I'll save this and I'll upload that to Avenue as well. But yeah, guys, we're over time for now, so I'm going to stop this tutorial. But once again, if you have more questions, feel free to reach out to me on Teams, and I'll try my best to get to them as soon as I have time. All right, thanks for being here, guys, and yeah, I'll see you guys next week for the next tutorial. All right, bye.